Hello everyone. Today I will present you the work that we did in Neurospin parcellating the Julich-Brain GapMaps using structural connectivity with Constellation. Okay. Oh. So there are people in this room that know more than me about the Julich-Brain, but I will give you some context. So the Julich-Brain was released as a 3D probabilistic cytoarchitectonic atlas and is in continuous evolution. And amongst the region of the Julich-Brain, there are some that are a bit special, that are called GapMap, and that are difficult to parcellate from the architectonics point of view. So this region were labeled as such to provide a whole brain parcellation, but the work is still in progress. So we had the idea in Neurospin to use a toolbox that is called Constellation and that is used to provide structural connectivity parcellation. Here you can have a look at the MNI column 27 Julich-Brain, the Julich-Brain in the MNI 27 reference space. So we use Constellation. I will not enter into too many details, but basically Constellation is used to using some white matter tracks, we compute connectivity matrices, and we separated these into a region of interest that here we call gyrus, and used it to define connectivity profile and connectivity basin on interest. These basins are the areas of the brain to which the region of interest is the most connected. So we use this trick to reduce back the individual matrices of the data set. And from this matrices that we average, we obtain with a camedoid clustering parcellation. So we obtain from 2 to 12 candidate cluster according to the degree of liberty. So from these clusters, we need to select one parcellation according to a criterion. So for this study, we used 200 subjects of the HTP 1200 subject dataset, and the probability, the FSL tractographies were issued from diffusion weighted MRI. We use free surfer white meshes, so in the FSLR referential, so 332K vertices by hemisphere. We use the brain visa environment and the Julich-Brain version 2.9 projected on the surface by the Neurivia. So these are the kind of parcellation that we obtained. So for different number of clusters, 6, 7, 8, and 9. So there are a lot of parcellation, as I said, and we need to select one according to a criterion. So for this study, we use the criterion that is 2 times the mean area of the Julich-Brain areas, so 300 millimeters square. This is the kind of maps that we obtain. So on the top, at the top, you have the original Julich-Brain with the gap maps in orange and brown. And at the bottom, this is the Julich-Brain with gap maps parcellated with Constellation. So this was printed with a 4-column theorem application. So, as I said, the criterion selection is a bit arbitrary. Like we took 300 millimeters square. We used to take in another study the silhouette criterion, but it's difficult to select the right one. So this study leads to a main question that we can ask ourselves is, can we find some links with the Julich-Brain, the original Julich-Brain, because we have two realities, a computational reality and an anatomical reality. And we have two modalities that are different, structural connectivity and cytoarchitectonic. So is there some link behind this? And Constellation can also be used to project an atlas onto individuals and obtain individual matrices and parcellation. So we could use this one, we can use this one to compute, for example, probability maps to assess the validity of a region. This is still an ongoing work. And finally, these connectivity matrices can be used to, can be given to a simulation of the brain dynamics. So, yes, that are part of my HBP work package. So, this talk is an introduction to the poster that I will present tomorrow at HIBALL. So, if you want to come and ask me some question about Constellation or the algorithm, feel free to come. And thank you for your attention.